My name is Sammy Jo Jones, and this is my anatomy assignment 1 for the skeletal system, scratching the surface. The axial and appendicular skeleton is the human skeleton can be divided up into two parts, the axial and the appendicular skeleton. Axial skeleton, which is the central core of the body, and the appendicular skeleton, which forms the extremities of the arms and legs. The appendicular, which is on the screen right now, has 4 bones in the shoulder girdle, which are the clavicle and the scapula, which is each side. 6 bones in the arm and forearm, which are the humerus, ulna and radius. And 58 bones in the hands, which there are 16 carpals, 10 metacarpals, 28 phalanges and 4 sesamoid bones. There are 2 pelvis bones in this, 8 bones in the legs, which are femur, tibia, patella and fibula. And lastly, 56 bones in the feet, which are the tarsals, metatarsals, phalanges and sesamoid. Next slide is axial skeleton, which is the axial skeleton is central core of the human body, housing and protecting the vital organs. The axial skeleton consists of 80 bones. 29 bones in the hand, 8 cranial, I hope I said that right, 14 facial bones, 8 cranial bones and 14 facial bones, and then also 7 associated bones. I'm sorry if I said that wrong. 6 auditorial ossicles and the hemorrhoid bone. 25 bones of the thorax, which is the sternum, and there is 24 ribs. And 26 bones in the vertebrae column, which is 24 bones in the vertebrae, the sacrum and the coccyx. Next slide is the type of bones, where you got the long bones, short bones, flat bones, irregular bones and sesamoid bones. The long bones are some of the longest bones in the body, such as the femur, humerus and tibia, but also some of the smallest, including the metacarpals, metatarsals and the phalanges. You wouldn't think that they are long bones, but if you look at the hand closely and when you look at the skeleton, they are quite big. Next one is the short bones, where you got the short bones are defined as being approximately as wide as they are long and have a primary function of providing support and sustainability with little movement. Examples of the short bones are the carpals and tarsals, the wrist, which is the carpals, and the tarsals are in the foot, like your ankle. So they consist of only a thin layer of compact hard bone with cancellous bone on the inside, along with relatively large amounts of bone marrow. Flat bones. There are flat bones in the cranium, optical, parietal, frontal, nasal, incremal and vomer. The thoracic cage, which is the sternum and ribs, and the pelvis, which is the ilium, ischium, and the pubis. The function of the flat bones is to protect internal organs, such as the brain, heart, pelvic organs, the lungs, and other ones like that. Flat bones are somewhat flatter and can provide protection like a shield. Flat bones can also provide large areas of attachment for the muscles. Irregular bones are vary in shape and structure. Regular bones vary in shape and structure of the body and therefore do not fit into any other category. They often have a fairly complex shape which helps protect internal organs. For example, the vertebrae, irregular bones of the vertebrae column protect the spinal cord. The irregular bones of the pelvis is the pubis, ilium, and ischium that protect the pelvic cavity. And next, the sesamoid bone, which is patella, basically kneecap. The sesamoid bones are bones embedded in tendons. These small round bones are commonly found in the tendons of the hands, knees, and feet. Sesamoid bones function to protect tendons from stress and wear. Next one is the function of the skeletal system, which is support, protection, shape, movement, and blood production. Okay, support is where it holds your vital organs in place when playing a sport like rugby or football. The vertebral column holds the body upright, so the position of your body is your posture. Next one is protection, where the cranium and ribs protect the brain and the vital organs in the chest. Your cranium protects your brain so your brain doesn't get damaged or anything, and the ribs and the rib cage protect your heart and your lungs. Next one is the shape, and it gives the shape of the body and makes you tall or short. Basically, it gives you your overall body look after you've developed all the growth and everything that you've had. Next one is movement, and muscles are attached to bones which are joined when the muscles contract with the bones and the bones move. Blood production. Red blood cells that carry oxygen and white blood cells that protect against infection are produced in the bone marrow of some bones. Next one, which is the fibrous. The types of joints is the fibrous, cartilaginous, and synovial joints. The first one is fibrous, which these are immovable joints and only found between the flat plate-like bones of the cranium and your pubis, as you can see in the picture here. There is limited movement up until about 20 years of age, when you turn 20, after which they become fixed. They are most important at birth, as at this stage the joints are not fused, allowing deformation of the cranium as it passes through the birth canal. Next one is I'm guessing, cartilaginous. It is found in the ribs, where they be split into primary and secondary cartilaginous joints. Cartilage is an excellent shock absorber, so it takes all the shock if you jump, or if you're riding a bike and you jump on a bike, it takes all the shock of your body, as it essentially is a thick gel. The pelvis and spine are hugely important in this aspect. Next one is synovial. The synovial joint is a joint filled with synovial fluid. This joint tends to be fully movable and are the main type of joint found around the body. They allow a huge range of movements, which are defined by the arrangement of their surfaces and the supporting ligaments and muscles. Next we go on to the joints, like the hinge joint. Hinge joint permits flexion and extension at the elbow joint and the knee joint, the patella joint basically, and it's where you extend your arm, that's extension. When you bring your hand back towards you, that's flexion. So when you're like having a bicep curl, you use that flexion and extension of the elbow joint and you bring up the weight. Next one is saddle joint. The saddle joint is a concave and convex joint which is in your thumb, and as you can tell, you can't move it completely in a circle as a saddle. As you're on a horse, it's like a saddle on a horse. So when you sit on the saddle, you can only go side to side, as you can't really go backwards and forwards. Next one is a plane joint. It's a gliding and sliding kind of joint, and it's in your collarbone and your shoulder blade. Your collarbone and your shoulder blade, where they slide across to keep you moving. A pivot joint allows rotation. A round bony process fits into a bony ligamentous socket. The examples of this include the elbow and neck joint, the top of the elbow and neck. Next one is the condyloid. The condyloid joint is the junction of two bones which allows movement and rotation every direction except the axial. It is also called an ellipsoid joint because the end of one bone is shaped like an ovoid head that fits into the other, which is shaped like an elliptical cavity. Ball and socket joint consists of a rounded ball-like end of one bone fitting into a cup-like socket. Yeah. Alright, the muscular system and the major muscles.